All right. I hopped on a little early so I can do this a better way. So yeah, for part two. Part two is a big old brute force mess right now. And I think there's a way I can do this with like a priority queue. So all I care about, or a map and a priority queue, like a map. Let's do that. Let's try it. Let's try it out. So if I made a map, and it's gonna have to be updated over and over. And let's map. We want to map the. What do we want to map? Oh, right. We want to map each ID to the first index, which there is an empty segment that file will fit in. So it's going to be mapping integer to integer. Oh, wait. No. It's going to be mapping integer to priority queue. How do you spell priority, dang? Priority queue, right? I should call it map for now. Did I spell that right? Priority queue. I know there's a priority queue in Java. Priority queue. Come on. If I do this one, it'll... Okay, sweet. Priority queue of integers. Okay. So part 2, map equals, yeah, we got to know how many file IDs we have, and that's gonna be like, if I have 3, it's gonna be 2, 3 divided by 2 plus 1. Or it'd be the length minus its length divided by 2. Length divided by 2 is 1. The length minus that is 2. Length divided by 2 is 2. Yeah. Oh, but it's always going to be odd. So, yeah, it's always going to be an odd number, right? Yes. Well, is it odd? I think it is. Yeah, it's like 19,999. The input. So, how many IDs do we have? Let's make that the length divided by 2. Yeah. Zero to data dot length divided by 2 plus 1. Whoops. So mapping each of those file IDs right here. Map each one of those file IDs to oh, actually, I don't really know how to. I could just say for each. Yeah, I'll do for each. For each, and I don't even need to do this. stream for each index. We're just gonna say for each index, I could just say map.put I new priority queue. Init that thing. And why don't I make a method for that? Init map I'm actually going to have it take the data. Oh. And let's give it the disk as well, right? The disk. Integer array. Okay, so we just initialize the map, and we want to map each file ID to the first index where there's a place that it would fit in. So for each ID, I want to do this. And for each ID, yeah, it's less than num IDs or num files. Oh, we called it num file. So for each ID, we're going to make its priority queue. Yeah. For a priority queue, don't I have to like pass? Where's my IntelliSense? Don't I have to like pass a like comparator or something? Well, I'm sure I can like. What is going on here? Where is my IntelliSense? What's wrong with you? There we go. I'm pretty sure you can like. Yeah, you can pass a comparator. Okay. So the comparator is going to be well, it'll just be numbers. And I think probably by default it's going to do minimum. We can throw a comparator in if I have to. So for each ID, we need to build its queue. Build, we'll just say map dot. Well, for each ID, while start is less than, we're going through the disk now, disk.length plus plus start, oh wait, while it's less than the disk.length and disk start is not equal to -1, that was my signal value, plus plus start. So that will get us to a period. And oh, yeah, just do this. I'll start. So yeah, while start is less than, and then here I'll say while start is less than disk.length and disk start is not equal to -1, an empty space, then plus plus start, and then int end equals start, and then I can say while end is less than disk.length and end minus start is less than, we need to get the length of the ID, or length of the file. We need to get the length of the file. And we can, for that, we can use data. So the length of the file is going to be the character, the integer value of the character at position ID. So length equals data dot char at ID minus character 0. That's going to give us the file length. And while in minus start is less than file length, plus plus end, and then down here I can say if end minus start equals file length, if it equals file length, then what do I do here? Priority queue, no, I say mapped dot get ID dot, what do I do? Add start, and then yeah, and then I say start equals end, no matter what. I think start equals end. Keep doing that. I think that does what we want it to do in init map. And yeah, I think so. And then defragment. Oh my gosh. We're gonna do this again. Private void defrag by file, or it's actually frag. I don't know why I keep saying, because it's, the problem is literally called fragment, disk fragmenter or something. fragment by file. We're going to take that disk, and this time we're going to go 4. How did we do it here? How did I get max ID? Okay, so that is the ID. Yeah, I'll do it like this. And we're going to work our way from the right to left. So that's our max ID. Oh, this is supposed to be an array. And then 4ID equals max ID. How am I gonna keep that thing sorted though? Yeah, it's gonna be kind of hard. How did people do that? I was watching a guy on YouTube do it earlier. I only got 10 minutes. I'll come back to it. Probably do it maybe tomorrow. I might never get to it. I don't know. How would I keep it sorted? Because you want to map the ID to the first index in the disk where that file would fit. And then once you move a file, then you have to, when you move a file, I gotta think about that one. Gotta think about that for a little while. Yeah, but this is ultra nasty. It's definitely brute force. I mean, it's not even that slow though. But the time complexity is like not good. What is it actually? Let's see. For part 2, defragment by file. I'm gonna rename this. Fragment by file and fragment by block. So this is O of n, this part, and inside of that we have, this is O of n. Yeah, this is O of n. So that's n squared. What about this? Find new location. This is O of n as well, so it's O of n. Oh, and then move file, so that's O of n cubed already. Move file. Move file is pretty small, but it's technically O of n. Yeah, it's not good. Yeah. Or like maybe K, like where K is the size of a file. Anyway, it's like, it's no bueno. Let's get set up for day 10. Oh sweet, it kept it sorted. So today's gonna be it's really like always the same. Simple little tests. D10. And I will have a sample. Okay. Alright, got a few minutes. What is this? I think it's like a little town or something. That's a Christmas tree. Weren't they like not in order last year? Yeah, they were kind of mixed around. Yeah, I only made it to day 12 last year. What was day 13? Oh man, I do remember working on this one. I do remember working on this one, never got it. Doing that reflection stuff. Ugh. Ugh. Please don't make me do that. Some of them are just like kind of a pain in the booty. Last time I put some copyright-free music on, my video got flagged, which was super lame. It was like copyright. It was no copyright. Maybe it was copyright. Yeah, day 9 is probably the first one of this year where I'm just like I feel it hitting me. This is just gross. There's like an in-log-in way to do it, part 2, with priority queues or heaps or whatever, keeping something sorted about it, keeping track. I'd have to probably watch some more people do it after this one. Yeah, first part, fine. Is the rest of this? Okay, the checksum. Man, that's gross. I think I can keep what I have here, maybe, and use and kind of plug in a map with some cues somehow. Basically, I'm checking that right here. Well, let's see. Well, I'm actually checking it kind of right in here too. And disk new begin is a -1. Yeah, I guess that's all you gotta check. Yeah. Yeah, how would you keep it sorted? It can't just simply be numbers in there. Can't just be numbers. Every time you... yeah, how would that be O of nlog n? How would that be nlog n? You would have to... I don't know. Maybe whoever was watching was mistaken. Oh, it's 10. Oh my gosh. It's lava again. Scared me. As long as I don't gotta do reflection. You all arrive at a lava production facility on a floating island in the sky. As others begin to search the massive industrial complex, you feel a small nose boop on your leg and look down to discover a reindeer wearing a hard hat. The reindeer is holding a book titled Lava Island Hiking Guide. However, when you open the book, you discover that most of it seems to have been scorched by lava. As you're about to ask how you can help, the reindeer brings you a blank topographic map of the surrounding area, your puzzle input, and looks up at you excitedly. Perhaps you can help fill the missing hiking trails. Yeah, maybe. The topographic map indicates the height at each position using a scale from 0, lowest elevation, 9, highest elevation. So here's a low point, and here's like a mountain or something. And it kind of like a cliff right here, looks like. Whatever. Based on unscorched scraps of the book, you determine that a good hiking trail is as long as possible and has an even, gradual uphill slope. For all practical purposes, this means that a hiking trail is any path that starts at height 0, ends at height 9. It's any path that starts at height 0, ends at height 9, and always increases by a height of exactly 1 at each step. Hiking trails never include diagonal steps. Okay, nice. Only up, down, left, or right. Sweet, I like that. From the perspective of the map. You look up from the map and notice that the reindeer has helpfully begun to construct a small pile of pencils, markers, rulers, compasses, stickers, and other equipment you might need to update the map with hiking trails. A trailhead is any position that starts one or more hiking trails. Here, these positions will always have height 0. assembling more fragments of pages, you establish that a trailhead score is the number of 9 height positions reachable from that trailhead via a hiking trail. In the above example, the single trailhead in the top left corner has a score of 1 because it can reach a single 9, the one at the bottom left. So, like, here's a hiking trail. You could go 4, 5, 6, 7, 8, 9. That's a hiking trail. 2, 3, 4. Here's a hiking trail. Like, you got a bunch of them there. But there's only 1 9 you can get to, so it has a score of 1. This trailhead has a score of 2, obviously. The position is marked with period impassable tiles. To simplify these examples, they do not appear on your actual topographic map. Okay. They do not appear on your actual topographic map. This is just for the examples. This trailhead has a score of 4 because every 9 is reachable via a hiking trail except the one immediately to the left of the trailhead. So you can't get to this one. There's no way to get to this. It's just like a cliff. Nowhere to get up there. This topographic map contains 2 trailheads. Boop and boop. The trailhead at the top has a score of 1 because it can get to this 9, and the one at the bottom has a score of 2 because it can get to this 9, and it can also get to that 9. Here's a larger example. This larger example has 9 trailheads. Considering the trailheads in reading order, they have scores 5, 6, 5, 3, 1, 3, 5, 3, 5. Adding these scores together gives you score. Adding the sum of the scores. Okay, the sum of the scores of all the trailheads is 36. The reindeer gleefully carries over a protractor, adds it to the pile. What is the sum of the scores of all trailheads on your topographic map? Okay, little something, some kind of problem. Some kind of problem we got here. And it should be 36. Okay. Oh. What? That should not have passed. Oh, we don't have tests above it. We don't have tests above these either, dude. Oh my goodness. Did we get him in there for day 8? We got to get before each in here too. Get him in here for this one? Yeah. We still have that override, that's fine. Alright. Sweet. So we just need to find each 0. and do a little DFS today is what we're gonna do, right? A little DFS. Yeah, DFS. So DFS you could do with recursion, or I can use a stack. Let's do it. What do you think? Let's do it recursively. So part one, guard data here. Let's turn it into a grid. Let's turn it to an integer grid. Equals, do I have one for this? No. It's gonna be a little bit different. Map each one of those. Split it by new line. Map each one of those to split. Split each number. Flat map to int. Flat map it to int each one of those. Well, I can say, let me think. Map each one to flat map to int each one of these guys. I can actually just say wait, might just flat map first. Flat map. HR, well, I'll just do doesn't work as nicely that one. Let's just get it done for now. Oh, this has got to be like a nice, pretty way. Yeah, this is dumb what I'm doing right here. Split by new line. Yeah. Come on now. Oh man, come on. Fur. What the heck? Come on now. What's going on in here? Oh, I just got like an extra bracket. What are you doing? Come on, autocomplete. It's my fault. Let's print it out, make sure it's good. What? Don't I have one for this? Yeah. I don't have one for that one. Totally thought I did. Yeah. Not test. Day 10. Well, we don't have that yet. We need to put the sample in a file. Sample, man. Where? Oh. What? What's going on? Did something wrong with my indexing and yeah, over here. Where is it? Parsers. Oh, it's gonna be the width. You might as well split it. It's definitely a better way to do that. Yeah, it's the width. Huh? Yeah, that should give us the row. Oh. Oh, what am I doing? What am I doing? I don't know, dude. I'm trying to get this done right now. I'm working way too long on like a utility method. I mean, data split. Yeah, let's join this. Or I could just say data dot replace. Data split dot replace all. What's wrong with you, man? Don't you have a replace all? Oh, it's a freaking string. Just join it then. String array. Dot join. Joined by nothing. Data split, please. Goodness. Trim data. Alright. Oh my gosh. What the heck is going on right now? I gotta trim it, don't I? Oh man, come on. What? Oh my gosh. What am I doing? What the heck, bro? I actually don't understand why this is not working. Let's see. Do it like... Turn it into a character matrix first, for Pete's sake. Just do that. Just do that first. Char grid equals char matrix. Yeah. And then should make an integer one. Dude, who is banging on stuff right now in my apartment? Somebody's like hammering something right now. It's like 10:30 at night almost. Driving me crazy. Ah, here's this ugly thing again. Dude, who is banging on stuff, man? Please. Finally, dude. I spent like 10 minutes on that thing, dude. Alright. Wait, I just got like a random. Okay, that's the print statement. Alright, sweet. Looks good. The grid is there. Grid's done. I have grid. So the next thing I want to do is... So have grid. We need to make a DFS. So I will do num trailheads. Wait. Yeah, for each trailhead, do a DFS. For each trailhead, do a DFS. And count how many 9s you can reach with that DFS. Right. So... I think you can do an int. Yeah. int DFS. It's going to take that grid, and I'm going to take the starting position too. Int I, int j. That's going to tell us where we're starting for this DFS. We're going to have a little score sum. It's going to take that grid and basically just going to go through the grid first, finding each trailhead. For each trailhead, run a DFS to get its score. And if it's a trailhead, run a DFS on it, or I'll say sum plus equals DFS, all that stuff, and then return that sum. Okay, and for a DFS, I'll have a recursive one too. DFS recursive. I'm gonna do it recursively, and it's gonna have a score, int I, int j, and z grid. And the way this is gonna work is we're just gonna return that. Return DFS recursive. It's gonna be a 0 ij, and then in here we want to go to the up, left, right, down neighbors only if they're one more than us. If we're 9, our base case is if we're at a 9. That's our base case. If grid ij equals 9, and return 1. And then 4, now how are we going to do this? I guess we could just make 4 calls. It's only I'm just going to make 4 calls. So we're going to have left score equals DFS, oops, DFS recursive score, you know, looks something like this. Oh, I thought I could hold the control. I swear I used to be able to do that. Score, so left score, I'll do up score first. Up score, down score, left score, right score, score, and up is going to be I minus 1. Oh. Yeah, you only want to do that You only want to search if it's one more than you. I can figure out a better way to do this. What if I did a for loop? I could do a for loop, you just need to ignore this might be better if I just it might just be better if I do this. I think I did this in a different one too, but I don't remember which one. I really should put these in like a utility file or something. So we got up, down, left, right. Now for each direction, if, oh here we'll do, yeah, int neighbor row equals I plus did and neighbor column equals j plus djd. Yeah, there's no wraparound. So if yeah, we can have the sum here. It's sum equals 0. Now if neighbor row is greater than or equal to 0 and neighbor row is less than grid.length and neighbor column is greater than or equal to 0 and neighbor column is less than grid 0.length and grid neighbor row neighbor column is grid ij plus 1, then I can DFS. Or I'll say sum plus equals DFS recursive. Get that score. Neighbor row, neighbor column, grid. Then at the end just return sum. I'll just call this DFS. And I'm going to call this NR for neighbor row. I don't need to get crazy with the names. Yeah. And I'm not changing anything this time, so I can actually put grid up here. Then I can have that. So I can just say grid here. and m equals grid dot length, n equals grid 0 dot length. Okay, then I don't need to pass this thing all over the place. So I'm not changing anything about it. Okay, I think that works. See if it does here in a second. And we just need to return. Yeah, we don't need even past that anymore. Return score sum. Okay, let's see what we're getting. 81. That is definitely not right. Let's look at this. IJ. Oh, you know what we're not doing? Yeah, we don't even need this. Now I just have 2. So if grid IJ equals 9, that's 1. What is it supposed to be? 36. We're getting 81 somehow. So if it's 9, return a 1. Go through each of the 4 neighbors. If the neighbor's not out of range, I can use and yeah, and it's 1 more than this guy. Go for it. Oh, we need a visited also. I forgot about that. For visited, I'll just use a set. Or yeah, let's use a set. Visited. Visited.add. We're going to do I times n plus j. And not visited dot contains I times n plus well, actually, neighbor row. Neighbor column. Yeah, that too. And then up here I need to pass it. Just pass a new hash set. Boom. There it is. Try it with the big one. I don't have it yet. This might be slow. We'll see. $822. Please be right. Yes. Yes! Yes! Dang. That's still my fastest one, I think, this year. I'm so slow. I think it was faster last year. The reindeer spends a few minutes reviewing your hiking trail map before realizing something, disappearing for a few minutes, and finally returning with yet another slightly charred piece of paper. The paper describes a second way to measure a trailhead called its rating. A trailhead's rating is the number of distinct hiking trails which begin at that trailhead. Okay. That's 81, right? Yeah, that was 81. So that was just without the visited. So for part 2, literally just get rid of visited. Right? DFS with visited. Call it that, I guess. And I'll have another one that doesn't have visited for part 2. No visited here. Don't even need that. Okay. So for part 2, it's going to be like the same stuff. And it's the same. Same score here. I'll refactor in a minute. I'll just call this score sum 2, and it's going to use just the regular DFS that doesn't use a visited. Man, I hope I'm right. All right, that was a fast part 2, right? That was a fast part 2. Now let's make it better. It's because I basically did part 2 before I did part 1. So how can I make this a little bit cleaner? I don't want 2 DFS. I don't want 2 DFS methods. I think that's enough for the stream. I'm gonna clean it up. Like, all the logics here just needs to be refactored. Thanks for watching.